So we were trying to find this, calculate. Yes, Steven.
Yes, sir. Please, good afternoon.
Yeah.
So pertaining to the graph, I was about to ask the question and the class ended.
Okay.
Yeah, you see that 45 degrees line.
Okay.
Yeah, there's an indication that one you've indicated it like you label like I. So I was confused that what that I means. Is it the investment or what?
No. We call it the income line.
Income line.
Income.
Oh, okay, that's why it's I.
Yet I was supposed to make it Y. You see that at times we represent income with I, but for this level it's supposed to be Y.
Okay.
Yes.
All right, thank you.
All right. We were trying to look at the last part where we are to find the level of income at which income equals consumption. Okay, where the two curves intersect. Okay, so graphically, this is what you do. Where the two curves intersect, this is the point where consumption equals income. But for you to actually know the exact level of income, you have to solve it. So we equate consumption to income. So equate the consumption function, which is a function of income, to income, then solve for income. We bring the 0.6 to the left-hand side. We have y minus 0.6y equals 600, okay? Then 1 minus 0.6 is 0.4. So we have 0.4y equals 600. Divide through by 0.4, we have 1,500. So we just come and indicate this, meaning the point of intersection, income is equal to what? 1,500. Okay, income equals 1,500. I hope that's okay. Are we together?
Yes, please.
Yeah, one.
Okay. Now we are to talk about the liquidity preference function and then the money supply function. Now the liquidity preference function is what we call the money demand function. Okay. Now according to Keynes, we hold money for transactionary, precautionary, and then the speculative motives. Okay. And then basically the transactionary and then the precautionary, they depend on income. Okay. For the sake of this analysis, we ignore the other factors, but then they both depend on the income level of the individual. But then the speculative function depends on the level of interest rates. Okay. But when we are drawing the function or when we are drawing the curve, we hold income constant. Then we look at the amount of money holdings that the individuals would like to hold at a particular point in time at the prevailing or the current interest rate. So when the level of interest rate is given, what is the amount of money that individuals will be willing to hold? So the money demand function or the liquidity preference function is a function that reveals the relationship between interest rate and then the quantity of money that individuals would like to hold, okay, at a particular point in time. Okay, so it's just a function that gives a relationship between quantity of money that people are holding and the interest rate. Okay, so that is the liquidity preference function, and then it is negatively related. The interest rate and then the quantity of money that we wish to hold are inversely related. Okay, so at a higher interest rate, we tend to hold a less amount of money. There are quite a number of ways that we explain this relationship, but then one simple way is that we see interest rate as the opportunity cost of holding money. Okay, according to Keynes, when you have wealth, when you have income, you can either hold it as money or you can enter into the financial market and buy something like a bond that yields interest. Okay, so as you are holding more money, you'll be left with a fewer amount of money for buying bonds. Okay, So the interest that we earn on bonds will be based on the level of interest rate. So when the interest rate is very high, it means that we can actually get more interest income when we buy bonds. So when interest rates are very high, we don't want to hold money. We rather want to buy bonds so that we can get more benefits there. So the opportunity cost of holding money, demanding money, is the interest rate. So what this means is that when interest rate is very high, people tend to hold less money. But then when interest rate is very low, it means that it is not very profitable to hold bonds. And if you are not holding bonds, it means that you have to come and hold money. Okay, that's why there's an inverse relationship between the quantity of money that we hold and the level of interest rate. Okay, that's why the curve slopes downwards. Okay, that's why the curve slopes downwards. And then for the supply of money function, that one too shows the relationship between the quantity of money in circulation and the interest rate. Okay, now at this level, we assume that the quantity of money is autonomous in that it is set by the central bank. Anastasia?
Yes, please. Please, I want to ask a question.
Yeah.
Please, I want to ask, what about, can you please explain to me the liquidity trap? What does it mean?
The liquidity trap is the case where interest rate becomes very, very, very low. When interest rates are extremely low, people just want to hold money. They don't want to hold any financial asset at all. That is where the liquidity preference curve becomes horizontal.
Okay.
That you see that we are saying that the interest rate is like the benefit that we get from buying bonds. Okay? When the interest rate is extremely low, we don't get much benefit from bonds. Okay, so when the interest rate is too low, people just tend to just hold money. They just forget about holding any interest yielding asset. Next semester in macro 1, you guys will talk more about that, so you get a deeper understanding.
Okay, thank you.
You're welcome. All right, so I was talking about the supply of money. It's exogenously determined by the central bank. Okay, so we take it to be a vertical line, which means that it's independent of interest rate. It doesn't matter the level of interest rate. The quantity of money in circulation is fixed. It's set by the central bank. Okay, so when we combine, this is the money market or the monetary market, and we know that when you have any market, the interaction between demand and supply will give us the equilibrium quantity of whatever good or service that is being traded, and then the price of that particular commodity. So in the money market, when we combine the demand for money and then the supply of money, we get our equilibrium interest rate. That is the cost of money. And then we get the equilibrium quantity of money or the stock of money that ensures that equilibrium. Okay, so we combine the two. When MT is equal to MS, that is where we get our equilibrium point. Now, whenever you have a market, if we can have an equilibrium point, we can also have this equilibrium. Okay, now we are saying that there's equilibrium when money demand equals what supply of money. That is where we have equilibrium. But it's possible that money demand can either be more than the supply of money, or money supply can rather be more than the demand for money. So when it happens like that, what are we supposed to do? And you need to know that whenever there's a state of equilibrium, when we deviate from that state, in the long run, we will always come back to that equilibrium point. So we have to know how the monetary market can always go back to equilibrium whenever there is a disequilibrium. Okay, so I think that's the next question. Given a disequilibrium characterized by excess demand for money. So here, the demand for money is more than the supply of money. So how will the market adjust to bring back equilibrium? Okay, to bring back equilibrium. So let's look at that. Now, let's assume that this is the initial equilibrium point where demand for money is equal to the supply of money. So equilibrium interest rate is R star. Now, if we pick a point here, okay, if we pick a point here we have a disequilibrium. The demand for money is more than the supply of money. So the money market isn't in equilibrium. So how do we get back to R star? Now let's look at this. The money market and then the bonds market or the financial market are parallel markets. Whatever is happening in the market will happen in the bonds market, but then in the opposite direction. Okay. Remember, there's an assumption that your money is either held as you either hold your wealth as money or you can buy bonds. So if you are holding more money, it means that you are buying less bonds. Okay. And then if you hold less money, it means that you are buying more bonds. So now if we look at our case here, money demand has increased. So we have excess demand for money. Excess demand for money. It means that when you go to the bonds market, the demand for bonds has fallen short of the supply of bonds. So whenever you have excess demand for money, it means that we have excess supply of bonds. Are we together? Whenever we have excess demand for money, it means that we have excess supply of bonds. And then from demand and supply analysis, we know that whenever we have excess supply of a commodity, the price of that commodity will fall. So excess demand for bonds will lead to excess demand for money will lead to excess supply of bonds, which means that the price of bonds will fall. Okay, the price of bonds will fall. And I hope we all know that there's an inverse relationship between interest rate and the price of bonds. Okay, so excess demand for money will lead to excess supply of bonds, which will lead to a fall in the price of what? Of bonds. And a fall in the price of bonds will mean that there's an increase in what? In interest rates. So whenever demand for money exceeds supply of money, will go through the bonds market, the price of bonds will fall, and then interest rates will go up. So this mechanism will keep on happening until interest rate gets back to R star. And by the time we get there, demand for money will exactly be equal to supply of money. But this is not a one-time something. This is what is going to happen. It's possible that initially the fall in the price of bonds will lead to this small increase in interest rate. So the interest rate will move from here up to this point. When it happens like this, you can still see that demand for money is still more than the supply of money. So the price of bonds should further fall, and then interest rate will keep on moving up until it gets to this point. And at this point, supply of money will exactly be equal to the demand for money. So we'll have equilibrium again in the money market. Okay, so this is how we move from this particular disequilibrium in the money market to equilibrium again. Let's look at the other side. Now, just assuming we pick a point here, okay, there is a point here. At this point, you will see that the supply of money is more than the demand for money. So interest rates will be higher than the equilibrium interest rate. So this one too, there's a disequilibrium. Money demand isn't equal to the supply of money. Now, this will mean that we'll have excess supply of money. So if you go to the bonds market, it means that we have excess demand for bonds. So when we have excess demand for bonds, the price of bonds will go up. When the price of bonds go up, because of the inverse relationship between the price of bonds and interest rate will fall. So assuming it falls up to this point, demand for money will get to this point. Still, supply of money is more than demand for money. So the mechanism will continue until we get to this point where demand for money will exactly be equal to supply of money. Is that okay? Are we together?
Yeah, one.
Yeah.
Okay, all right. So that is that. Any question? Right, so this is the information that we have for the simple Keynesian model. We have been given aggregate expenditure as a sum of consumption, investment, and government spending. Disposable income is income minus tax, and then the transfer payment, kill, okay? We take investment, government spending, transfer payment, and investment as autonomous, okay? So they are not dependent on income. Then tax has only the income induced tax component. There's no lump sum tax. There is no autonomous tax. So that big T isn't here. But most of the times you see the big T there. It doesn't matter. You just have to use it if it is given. Then consumption. Yes, please. I will share the documents and the video with you. Okay. And then consumption 2 is equal to marginal propensity to consume times disposable income. Okay, so this one too, for the consumption function, there is no autonomous consumption. Okay, so, and then the restriction on T and C is that they are all between 0 and then 1. They are all between 0 and then 1. So first, our first task is to find aggregate expenditure and equilibrium income functions, aggregate expenditure and the equilibrium income function. So let's do that. First, let's find the aggregate expenditure. Now, aggregate expenditure is given as the sum of consumption, investment, and government spending. As for investment and government spending, we are taking them as autonomous, okay? Investment will not always be autonomous. Even I think next semester, you see, it depends on investment. It depends on interest rate. It's even possible it depends on income as well. Okay. Now, if you come to consumption, consumption is CYD. Okay, CYD. And remember, disposable income is Y minus T plus what? The transfer payment. And remember, transfer payment too is autonomous. So C times Y minus T plus Q star. Okay, then our autonomous investment and government spending. So we have to question 3 and 4 of what? Is it last year's paper? It's part and we'll get there. Okay. So C, the consumption function has been expanded as CY minus CTY plus CQ. Then we have investment and then government spending. So this is the A part. This is the aggregate expenditure function. Okay, this is the A part. Now, if you want to find the equilibrium income function, we have equilibrium when income is exactly equal to what? Expenditure. So we equate E to Y. Okay, we equate E to Y. So now Y should equal to the E, which is CY minus CTY plus CQ plus I star, and then the J star. So we have to group like terms. We want to make Y the subject. So we send all the Y components to the left-hand side. So bring CY here. We'll have Y minus CY. Then this is minus, so it becomes positive here. Okay, CTY equals the autonomous components, CQ star plus I star plus J star. So we factor Y out. When we take Y out, we have 1 minus C plus CT equals the autonomous. So we divide through by 1 minus C plus CT. Now, if you simplify this or you factorize, you get minus C, 1 minus T. Please, most of the times it's B that we use, but if the question is using C, please just use whatever was given in the question, okay? So Y star, which is our equilibrium income or the equilibrium income function, is giving us 1 over 1 minus C times 1 minus T times the autonomous component. So the 1 over 1 minus C times 1 minus T is what we call the multiplier. Okay, this C is marginal propensity to consume, and then the T is the tax rate or the marginal tax rate. Okay, so that is the first part of the question. Any question?
Hello, say.
Yes, please.
Hello.
Yes, I'm here. Josephine. Hello, can you guys hear me?
Yes.
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 Sebi, with the disequilibrium, the money supply. You said when there is a disequilibrium, you go back to the initial money supply.
No, you don't go back to the initial money supply. You go back to the initial equilibrium point. After you've gone through all the mechanisms, you have to go back there.
Okay.
Yeah.
Okay.
And
Thank you.
Please, a note there. When we are on a particular question, if you have a question there, please you make sure you ask it there. You don't let us move on until you understand it. Okay. Don't let us get to another one before we have to go back again. Okay. All right. So let's look at the B part. We are to use either the output expenditure or the withdrawals and injections approach to illustrate graphically and discuss the effect of the following on equilibrium national income. I use the output and then expenditure. If you want to use the other one, you can try that one too later. The first one is a decrease in government expenditure. Okay, now if there's a decrease in government expenditure, let me talk about the intuition first before we look at the graph. Now, government expenditure is part of aggregate demand or aggregate expenditure. So if there's a reduction in that, it means that there's going to be a reduction in aggregate demand. Okay, and if there's a reduction in aggregate demand, that should cause a reduction in the equilibrium income or the equilibrium output. Okay, now graphically, let's start from this equilibrium point. I forgot to label all the curves, and so the ones I didn't, please, when you are going over, you make sure you label them. You can't draw curves without the labels. They will cancel it. Okay, but I had to solve the question this morning. I was in a bit of a rush. Right, so let's start from here. This is the initial aggregate expenditure with. Is someone saying something? All right, so this is the initial aggregate expenditure curve, okay, drawn with a given level of government spending. Let's call it G0. So when it intersects the 45 degrees line, that's where we get our equilibrium income, Y star. Now, the question is that there's a reduction in government spending. If there's a reduction in government spending, the aggregate expenditure curve will shift downwards. So it will shift from E0 to E1. E1, see, I wrote E0 again. Here supposed to be E1. Okay, so this E1 is drawn at a given Gen 1 of government spending. Okay, so now when the aggregate expenditure curve shifts downwards, then this is going to be the new level of income or the new equilibrium income. And this Y1 is lower. Please, can you mute yourself? This, the new income is lower than the initial one. Okay, so the effect is that whenever there's a reduction in government spending, there is a reduction in equilibrium income. Okay, there's a reduction in equilibrium income. Are we together?
Yes, please. We are together.
Okay. Then the second one is an increase in the marginal tax rate. Okay. Now you need to understand that taxes are imposed on firms and then individuals, so it affects consumption and then investment. Now, when they increase the tax rate, it means that either consumption or investment will fall. Okay, either consumption or investment falls. But then the marginal tax rate is part of the Keynesian multiplier. Okay, so it's part of the slope of the aggregate expenditure curve. Okay, so that one, a change in the marginal tax rate doesn't cause a shift, it causes a rotation. It causes a rotation in the aggregate expenditure curve. So here, because of the increase in the marginal tax rate, the aggregate expenditure curve will rotate downwards. Okay, it rotates downwards, so it will move from this E0 to this E1. So equilibrium moves from this point to this point. Equilibrium income moves from Y star to Y1. You see, the reason is that the marginal tax rate will cut down consumption and it discourages investment as well. And consumption and investment are components of aggregate demand. So when they reduce, aggregate demand falls and then the output level will as well fall. Okay, so an increase in the marginal tax rate will reduce the equilibrium income. Please, you need to understand the other side. If there's a reduction or a cut in the marginal tax rate, then the aggregate expenditure curve will rotate outwards. So that should cause an increase in equilibrium income. Okay. Yes, iPhone. iPhone, your hand is up. All right, any question? Any question? Right, if you take this one, we are saying that we want to use graphs to show the effect of an increase in the marginal tax rate on income. Okay. Now, the marginal tax rate is a component of the Keynesian multiplier, and that gives the slope of the aggregate expenditure curve. Okay. So, if there's an increase in the marginal tax rate, the aggregate expenditure curve rotates downwards. Okay. There's a reduction in either consumption and investment, or even both, and they are all part of aggregate expenditure or aggregate demand. So whenever there's a reduction in aggregate demand, holding aggregate supply constant, we should see a reduction in income. That is why income falls from Y star to Y1. Okay. Yes, Kid. I see you do.
Please, can you please re-explain the A part for me? I didn't get it well.
Which part? Kid, is it
the A, algebraically derive the aggregate expenditure in equilibrium? Yes, please, can you hear?
All right.
Yes, the A.
Yes, so you just, the aggregate expenditure function was given as the sum of consumption, investment, and government spending. So we are just doing substitution. It's a consumption that we have to deal with, okay? Consumption is a function of disposable income. So consumption is equal to CYD, but then YD is equal to Y minus T plus Q. So just instead of YD, put Y minus T plus Q there. Then we expand. Okay, we expand. When you expand this, you get CY minus CY plus Q. So this is the expenditure function. Is that okay? Then if you want to get the equilibrium income function, you equate this expenditure function to income. Then you just make income the subject. Okay, so you have to get something of this form, where this is the Keynesian multiplier, and the ones here will be the autonomous expenditure. It's not always like this. This one, there is no consumption, autonomous consumption. There's no autonomous tax. Okay, so if those ones are part, they will be part of the autonomous expenditure. Yeah, Dominic. Mr. Dominic, please, do you have a question? All right, so please let's go on. The next part, we are to define and algebraically derive the transfer payment and government multipliers. Okay. Now, in terms of national income accounting, when we talk about the multiplier of a particular component of variable, we are looking at the change in income resulting from a unit change in that particular component. So when we talk about the transfer payment multiplier, okay, then by definition, we are talking about the change in income as a result of a unit change in transfer payment. So if the government increases its transfer payment by 1 unit, what is going to be the effect on equilibrium income? That is the transfer payment multiplier. When you go to government spending multiplier, it measures the change in equilibrium income resulting from a unit change in government spending. So if the government has to inject something like 1,000 Ghana cedis into the system, what is going to be the effect on equilibrium income? That is what government spending multiplier measures. Okay. Now, if you want to use algebra to find them, then you differentiate equilibrium income with respect to that particular component. So this is the equilibrium income function. If you want to find transfer payment multiplier, then you differentiate Y star with respect to Q star. Okay. If you want to find government spending multiplier, you differentiate Y star with respect to J star. So please let's do that. Now from here, if you differentiate Y star with respect to Q star, that is changing Y star, over changing Q. Okay. And I'm sure by now you know how to do differentiation. You did Econs last semester, so you should be able to differentiate this. So changing Y over changing Q will be C over 1 minus C times 1 minus T. Okay. And then if you want the government spending multiplier, changing Y over changing J will be 1 over 1 minus C, 1 minus T. That is this. So this is the government spending multiplier. This is the transfer payment multiplier. You see that I was trying to tell you that the equilibrium income function is not always like this. If they add autonomous tax, okay, we're supposed to have this component CT. Okay, that one is minus CT. It's minus CT. Okay, you can also be asked to find the autonomous tax multiplier. That one, you differentiate this Y with respect to this T, you get minus C over 1 minus C, 1 minus T. It's just the opposite of the transfer payment. The transfer payment is C over 1 minus C, 1 minus T, but then the tax one is minus C over 1 minus C, 1 minus T. So in terms of magnitude, the tax multiplier and then the transfer payment multiplier are the same. They are the same in magnitude, but then they act in opposite direction. So if you increase tax by 1, and then you increase transfer payment by 1, then the increase in tax will cause a reduction in income by the same amount that the transfer payment will cause an increase in income. Okay, they are of the same magnitude, except that they move in opposite directions. Okay, and then the next question, we're supposed to compare the transfer payment multiplier and then the government spending multiplier. Now, this is for the transfer payment. This is for the government spending. If you look at the two, the government spending multiplier is always greater than the transfer payment multiplier. And this is the reason. Mathematically, DC, there's a restriction on DC. Remember, it's less than 1. Okay, DC is less than 1. Okay, this is the C is less than 1. So if C is less than 1, then it means that the numerator here is greater than this one here. So definitely this ratio here will be larger than this. Always, you can prove this by using some numbers for C and then T. Assuming C is 0.6, T is 0.2. Fix them inside and see. You will see that the government spending multiplier is greater than the transfer payment multiplier. And now the question is, why is it so? Why is it so? This is the reason. It's part of the questions. The reason is that for government spending, it gives a direct injection into the goods and services market. When the government is spending, it is spending on goods and services. It is directly buying from the market. So it directly enters aggregate demand. So if we are spending 10,000 as government spending, all the 10,000 is going into the aggregate demand. Okay. But then if you go to transfer payment is going to a component of aggregate demand, maybe to the firm or to the consumer. Assuming the transfer payment goes to the consumer in the case of this model. If it goes to the consumer, remember, marginal propensity to consume is less than 1. So whenever there's an increase in the individual's income, he doesn't spend all, he saves some. So not all the transfer payments will be injected into the goods market. So not all will form part of the aggregate demand. For example, if C is 0.6, then it means that if the government transfers 1,000 Ghana cedis to the individual will only spend 600 Ghana and save 400 Ghana. And remember, savings is a leakage. Savings is a leakage. It takes something out of national income. So if the government is transferring 1,000 Ghana, only 600 will enter into the aggregate demand. But then if it's through government spending, then everything is going into the aggregate demand function. That is why the impact of government spending is always greater than the impact of transfer payment. Okay. The meeting will go off soon, so you have to wait. All right. When we get back, I will give the